Good morning, everybody. In any lab, we have to measure trace metals in any samples, liquid, solid, and gas with special conditions. Trace metals analysis is very important in any laboratory, and inductively coupled plasma, or ICP, is most important instrument in this field. What does it mean, inductively coupled plasma? What about how to measure it? Uh, what about how to prepare the samples? Uh, can you measure this element directly, or you have to dissolve sample, or you have to make digestion for sample, use the microwave, use the ultrasonic? When you measure it, what you need when you work to inductive coupled plasma, what you need to learn is their basic principle important to know. What about the maintenance of this instrument? What about troubleshooting? If you work on it and suddenly there is troubleshooting, how to solve it? How to make evaluation for your data, for your result? All this point, we will speak about all this point in this course. I hope you register to learn more about inductively coupled plasma. As an introduction, this instrument is called inductively coupled plasma, which meaning is double radio frequency effect on argon gas to form plasma. Plasma is not flame. Plasma is ionization state, and the state of matter, the fourth state of matter. State of matter is solid, liquid, and gas. This is special state of gas, which mean gas in the form of ions. Ionization energy of argon will form heat or energy, highly energy equal 10,000 Kelvin degree, which can be make emission for any metals, any trace metals, whatever concentration, with very, very low detection limit to measure it. Spectroscopy, as we know, there is two difference of spectroscopy, atomic spectroscopy and molecular spectroscopy. ICP is atomic spectroscopy. Atomic spectroscopy can be divided to fluorescence with X-ray instrument and atomic absorption with atomic absorption spectra, which consists of flame and graphite. And the third part is atomic emission. Atomic emission is converted to three types. Atomic emission with atomic absorption spectra is combined with it for measurement of element with high emission like sodium, calcium, magnesium, lithium, and so on. Flame photometer with measure sodium, potassium, calcium, which have in outermost shell 1 electron or more, to make emission for it with low temperature LPG or natural gas energy to make atomization for sodium and potassium, then measurement by emission spectroscopy. ICP is emission spectroscopy, but with high temperature, which can measure any element with low detection limit. Consists of coil made from copper to make highly electrical conductivity. This is coil is tube. Inside it there is water to make cooling, because high temperature can melt the copper coil. And the magnetic field, there is magnetic field in this area and this area, so we call it inductive coupled. It's mean radio frequency double coupled of inductive, and argon gas with a start spark will form plasma flame or plasma ionization state. In plasma ionization state, what highest temperature when sample come from this injector in quartz torch. This is quartz torch made from quartz to resist high temperature, and this is injector for sample come in this area, make atomization, then make emission emission, wavelength of emission is go to optical system to measure by detector. All these components, we will speak in details about it. We have to discuss everything about ICP to be professional in measurement elements or trace metals in ICP. All this point with maintenance, with troubleshooting, with study and evaluation data results, we have discussed in this course. Thank you.